The goal of this project at the physics department at Furman University is to use the Bluetooth sensor board from a Sphero mini robot for at-home remote teaching physics labs. Take the Sphero robot apart, strip away all the components except for the Bluetooth sensor board inside, and what you have here then is a 6 degree of freedom inertial measurement unit with an accelerometer and a gyroscope, which the students can use in their at-home teaching labs. I contacted Sphero in April of 2020, and in June, mid-July, they donated 44 Sphero minis for this project. My wife and I started to take them apart and ship up boxes. Here's how you turn a Sphero mini into a Physics 111 remote sensor board. The two shells come apart. Two screws hold that idler wheel platform here. That shell comes off, that goes there. This is held in place with two little tiny screws. So the board comes off then, and we have to gently pry out the battery. Sometimes it comes out pretty easily. Yeah, here it is. Okay. We want to mount the battery tightly to the board so it doesn't flop around. So we take a piece of 3M mounting tape, stick it on the back side of the battery. Here, peel off the adhesive protector piece there, and then push the battery down onto the board, centered about like that. So there's the unit ready to go. My wife and I then proceeded to pack up 36 of these units as at-home kits for the students, packed them up and took them to the Furman post office for distribution to the on-campus students and those who were taking the course at home. The first experiment we'll be doing in the course with the Sphero mini sensor board. It's a Slingshot Sled Kinematics experiment. It simply involves position, velocity, and acceleration. You use the Sphero mini sensor board to measure the acceleration as a function of time, and then this Mathematica document that you're looking at on the screen now integrates the acceleration to get the velocity, and then integrates the velocity to get the position. Here's the experimental procedure. I'll show you how to build the sled that you'll use to take the data. What we're going to do is take an elastic, a piece of elastic, stretch it between a support structure down here and some initial starting point. So we start from here, we let go of the sled. The sled starts to accelerate in this direction because of the spring tension in the line here. It has an increasing acceleration up until the point where the spring string relaxes to its unstretched length L0. Okay. After this point, the spring is no longer a spring, it's just hanging there in the breeze, and the particle continues to slide forward until it comes to a stop. Okay. So there's acceleration from here to here and deceleration between here and here. Here's how you build the sled. Start by tying the end of the string, the elastic, into the hole in the sled ruler, and then take a little chunk of 1/4 of a Kleenex tissue, fold it, take the SMSB and put it with the battery side sticking up in the bottom of the plastic cup. Take that Kleenex spacer and put it there. That way. You want to mount that on the slide. So here, and again, you want to make sure that the tape doesn't get onto the bottom of the sled. Try and line it very carefully. That looks pretty well. And they want to get taped to the back of the sled, so you can put them back here like this. Again, nothing terribly crucial. Put it there, and you can tape to it. And there's the ready-to-go sled. Beautiful, huh? Not like the rocket sleds of the NASA program, but there's the sled. The string is pulling this way. The USB port is pointing back that way. I'm going to let go. And then as soon as I do that, there's the data. So I'm going to stop now. There's the acceleration up, positive acceleration, negative acceleration while it's slowing down. You want to take the CSV file that we just captured. That's this run here, run 1, and we're going to drag it into this place here between the Excel data equals, this blank space, and that there. And we do that, and we hit a carriage return here. We hit Shift Enter again, and that generates the data file then that you saw in the video. Here's the acceleration as a function of time. The last step then is to analyze that data by coming down here to put the cursor at the end of this section here. In step 4, you put the cursor here, do Shift and Enter, and then it gives you velocity as a function of time
and position as a function of time. Okay, and you can actually pick data values off of this curve here. See, the velocity peaks at about 2.5 meters per second here, and you can see where the position stops at about 4 meters, like that. Okay.
So with that brief introduction, let me summarize by saying that this academic year we've developed a total of 6 complete labs. Here are 6 complete videos from the Furman Physics YouTube channel. We have curriculum material available for that. Sometimes they are Mathematica documents, sometimes they are Microsoft Word documents, sometimes a combination. In summary, we think the Furman Physics modified Sphero mini sensor board is a very viable platform for doing these kind of remote at-home experiments, and we think there's a real future for them. Thanks for your attention.